Hello friends, in this video I'd like to solve the following problem from the Saudi Arabia Balkan Mathematical Olympiad Team Selection Test 2013, problem number 10. We want to find all functions f from the set of real numbers into itself such that f of x plus y equals x plus y plus f of y for all the real numbers x and y. This functional equation turns out to be very simple. Here are my hints. It's all about injectivity. First, set y to be 0 and justify that our function must be injective. Then set x to be minus y and use this injectivity a bunch of times. And also recall this well-known fact that if we compose two functions, h with g, and if this composition is injective, then the inner function g must be injective as well. So give this problem a try and I will see you in just a minute. Okay, so here is my solution. So as I suggested, let's start with set y to be 0. Then we have the following. f of x equals x plus f of 0. Very well. Notice, on the right hand side we have an affine function, and this is injective. Yes, because two different x's give two different values. But on the left hand side we have a composition, and the most inner function is f. So this function f must be injective as well. Must be injective. In fact, it must be bijective, but we will only need injectivity. Now let's set x to be equal minus y, crucially. What do we have? On the left hand side, we have f of minus y, rather, minus y plus y equals minus y plus y is 0, so that equals f of y. And maybe I will mark this outer occurrence of f in this teal color. Now we'll use injectivity. Since our function is injective, we can cancel this outer occurrence of our function by injectivity. Yes. So we have now f of minus y plus y equals y. Is it right? It is. It is right. And that means that f of minus y plus y equals 0. Very well. And now let's set something new. Now let's set y to be 0. If y equals 0, then we have the following. f of 0 equals 0. Okay. Now let's compare. Let's maybe mark this condition square and this condition triangle. By these two conditions, we have the following. f of minus y plus y equals 0 is actually f of 0. Perfect. And now, once again, here we have f, here we have f. Function is injective. Yes? Function is injective. So we can cancel this outer occurrence of our function, which means that f of minus y plus y equals f of 0, which means in turn that f of minus y equals minus y plus f of 0. Plus f of 0. Perfect. Now, we have just established that for every x, for every real x, changing minus y to x, f of x must be equal x plus f of 0. Very well. Now, can we find f of 0 in some way? Can we find f of 0 in some way? Yes, we can. Once again, by our condition which I marked triangle, we have the following. F of 0 equals f of 0 plus f of 0, but f of 0 by my condition triangle, it's just 0. So f of 0 needs to be 0. F of 0 equals 0. Perfect. So in other words, for every real number x, f of x equals just x. But now we need to verify, but verification is very simple. Verification, left-hand side, on the left-hand side of our very first equation, we have f of x plus y plus y. And that's just x plus y plus y. And on the right-hand side, we have x plus y plus f of y, and that's also x plus y plus y. So it's verified. So the only solution f of x is identity. So f of x equals x for all real numbers. And that's it. That closes our problem. So it was all about injectivity this time. Thank you very much for watching. I will see you next time. Goodbye.